think we have everything set up nicely. Okay, pre-calculus is about functions. What is a function?
It's used to describe some pattern.
Let's describe some pattern. I like it. Definition. Oh, yeah. Actually, let's do this. Let's go into definition of a function. Excellent. All right, so it's what do you need for a function? What does a function do? Go ahead.
When you plug in, you input it, comes to the result.
Right, so there's something that goes in and something that comes out, right? Something goes in, something comes out. Okay, right? That's it, right? With a little caveat, right? So that functions are about relationships. Functions relate to things, right? So right now, what I'm about to do, here's my style, right? What I'm going to do this whole semester is I'm going to try and talk through what something means to us in words, and then I'm going to change it to mathematics. Mathematics is nothing but a language of the world, okay? And so what we've done to mathematics is we've made it so rigid that it's inaccessible, right? And so my job is to say, okay, we all know about relationships. Here's how functions relate to relationships, right? So I got one thing over here and another thing over here, and I want to relate them, right? Now, I just don't want to relate them in a weird way, right? So I could have ages, right? So I got some 17s, who's 17 in here? Oh, wow, I hit the jackpot early. 18? Any 18-year-olds? 16-year-olds? 15-year-olds? Okay, so I got ages over here, and we got us over here, right? I got me, you, right? And so it's clear to make a relationship, right? So is that a function? Us to our ages?
No.
No? Yes? Okay. So I'm 40, right? So I get assigned to 40. You get assigned to 17. 17. 17. 16. Function?
Yes. No.
Okay. So what we want to do is this. We don't want to say something ridiculous, right? We don't want, so whatever a function is, we don't want it to be crazy, right? So I don't want to say, here's what I don't want to do. I don't want to say I am 40 and I'm 39. I don't want to do that. Whatever a function is, I don't want it to be okay for me to be both 40 and 39. So the things over here should only go to how many things over here? One thing. I want to be clear about something. It's okay for things over here to go to the same thing over here, right? So two people can be 17. That's okay. So capital A is a relation that associates each of us to our ages. Is that relationship a function? Yes or no?
Yes.
Yes. Why? Because each thing over here has
Something.
not something, not just something. One and only one thing. One and only one thing. We each have one and only one social security number. We each at this moment have one and only one weight. We each at this moment have one and only one first name, right? Those are functions, okay? Here's the definition. A function is a relation. What do I need before I even start? Two things. What are those things called? Begins with an S. 3 letters. We get to play hangman already? No. 1, 2, 3. A set. That's right. I need 2 sets. Right? And what's special about these sets? Now I'm being anal as a mathematician. They have to have something in them. Right? So the sets have to be non-empty. Right? So I need 2 sets, A and B. So I'm going to let those sets occur. Let A and B be 2 non-empty sets. And we can talk for hours about why some mathematicians care about sets that are empty. That's a completely different conversation. But we want two non-empty sets. A function is a relation that assigns to each x in A what? One and only one thing we call f of x in B. The exponential function, the logarithmic function, polynomials, linear functions, trig functions, they all satisfy this. Right? The sine of pi over 2 is one and only one thing. No pun intended. It's one, and it's only one thing. The natural log of e to the 7th is 7, and that's it. Right? A is called the input. It's called the input. It is called the input. Absolutely. It's what you put in. You're gonna put, so A is called the input place, right? So now, here's the deal. We don't say input place, right? So I'm gonna give you a new name, right? So this is what I mean by mapping a language, right? And so what I have found is that it's the language that in a lot of ways is the problem, right? So instead of saying input place, I'm gonna call it the domain. A is called the domain. All right, so there's a whole set of language. So here's the deal. I'll be saying domain like 372 times, right? This whole semester we have together, right? Because every time I talk about a function, I'm going to talk about its domain every single time. Why? Because look at the definition. The first thing you need are the two sets. There is no function without the sets. There's no function without those two sets, right? So A is called the domain. B is called the range. Excellent. We'll do some examples. All right. Here's A, 179. Here's B, X, M, Q. Let's get some arrows. I can just do this. That. Function? Yes. No? Read the definition.
Yes. Yes.
Okay, so the question becomes, right, so what I'll do is we'll talk about this mathematically and then I'll give the street version. So the street version is, just tell me quick, what are you saying, right? So super quick, yeah, right? So the mathematical version says that this is a function if for each one of these goes to one and only one of these, right? Does this go to something?
Yeah.
How many things?
One.
This?
One.
This?
One.
Function?
Yes.
Questions?
No.
So if each thing goes to only one thing over here, then the answer is yes, okay? The street version is, there's only one arrow coming from one of these. There's only one arrow. No one of these has two arrows. Just one arrow. Okay. They all go to X. We need to draw something that's not a function. Oh, I can do this, right? Right. A, B, 7, 3, 2, A, B, C. 7 goes to A, 3 goes to A, 2 goes to B, 2 goes to A. It hurts my mind just to do that. Right? Somehow 2 gets assigned 2 things. That is no good, not a function. Okay. Questions about that? Let's hit what MyOpenMath looks like. So there's an assignment for free points where you just practice in MyMathLab. Have you seen that one? This one right here? Just go in and it helps you just start putting in stuff. Okay? So that assignment's due on the 8th as well. Here's what the first assignment looks like. So again, there are the materials. So there are going to be tons of video lessons if you so choose to look at them, right? The first one is a video assignment. You click on that thing, it opens up, and then you should see a link to a video, and then after the video, some assignments, right? So this one's going to talk about some word problems and then go through them, and then when you go through these examples, they should be similar, right? Or you can just try and do those without looking at the video, right? So that's an introduction to functions, right? So, but then the assignment is this. Okay, so it starts off with a word problem, right? The amount of garbage G produced by a city with a population P is given by G equals F of P. G is measured in tons per week, and P is measured in thousands of people. The town of Tola has a population of 20,000 and produces 8 tons of garbage each week. Express this information in terms of the function. So first thing we'll do, of course, is we'll just take a deep breath and say that we are not afraid of this problem. If you want help, you can click on the video, right? So now, we're trying to relate things, right? So it says G is a function of P, right? So G is a function of P. So this means that we got some stuff over here, right? And G is going to take something to something, right? So what I care about, what we care about in this case, is something that we often don't care about in society, and it's units. This problem can be solved just by looking at the units. What are the units of the domain? What are the units of the domain? Thousands of people. The units of the domain are people. You put in people, you get out garbage. In what units? Tons. Tons of garbage. That's right. That's right. So this one's in people. This one's in tons. Right? They tried to tell you, well, they tried to hide a relationship that we're making. So what's going over here? People, and coming out here? A, B, or C? Which one is it? So what should go into F? It should be people, right? Yep. And out should be tons. Let's see. Yeah. Yeah. But in 20,000, get out 8 tons of garbage. Questions, please.
About the ton, isn't ton 2,000?
It is 2,000 pounds.
So wouldn't you have to make it like, if you want to change the 20,000 to 20, let's turn the 16,000 to 16?
That's a great question. So why didn't we change this to 16?
We didn't convert.
Yeah, we didn't. Why not?
Because G is measured in tons.
Because it says it's in tons. It wants to be in tons. G, right, the amount of garbage, right, is measured in tons, right? So you would be right if they wanted it in pounds, right? Yeah, so absolutely it would be 16,000 if they wanted it in pounds. But yeah, the word problem said, yeah, let's keep it in tons. Why is this not 20,000?
Because it's measured in thousands.
Because it's in thousands, right? They want it to be in thousands. So they're saying that we want you to remember that this 20 represents 20,000. Good, good. Other questions about this? Thank you for your question. Okay. Let's see how Open Math deals with that. Oh, you can just click on that, press submit. Let's see. That's good. 10 points. Let's roll through. The question is, are these functions? So we need to look at some graphs. The street version of a function. What's a function? Right. So the street version. You're at the mall. Someone's like, "I need your help. I need your help." What's a function? Right. So what is it? It's a relationship, right, between two things, right? Where for each thing here there is. All right. So let's get the street version out. For each x, there's only one. That's a function. That's the street version. And then if that's not sufficient, you can start talking about sets and all this other nonsense, domains, ranges, whatever, right? Just depending on who you're talking to, right? So what we want you to be able to do is to be able to talk in all settings about this, right? So street version for each x is only one y. The mathematical version, let A and B be sets, blah, 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 right? And when I say blah, 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 don't tell any of my colleagues that. They'll be like, well, you need to, right? So, okay. For each x is only one y. For each x is only one y. For each x, there's only one y. For each x, there's only one y value, right? So for each x, like 5, there should only be one y value. Function? No. Questions on that? Right. This is not a function. Here's an x value that gets associated with the square root of 5, right? And minus the square root of 5. When x is 5, y squared is 5. You have to take the square root of both sides. You take the square root, you get a plus and a minus. This is not a function. And of course, we can move this thing. Oh my goodness, this is why I love this thing, right? Right, so I can move this, right? And then we see that we got some problems there, right? For each x, there's only one y. For each x, there's only one y. Function?
Yes.
Yes. For each x, for that x, one y. One y. For each x, there's only one y. Seems like when I have a graph, I can figure out whether, and I'm being biased, this thing, what's the domain of this thing? It looks like I just graphed y equals x squared. What's the domain? Right, the whole real line, right? Now, what I was about to do, and which I will do, because this is how I've been raised in the mathematical environment, is that sometimes I'll put up a function and I won't even say what the domain is, right? I'm always supposed to say the domain. So if I don't say the domain, then the convention is it's the largest possible set that it could be, right? So in this case, it's the whole real line, okay? Can you look at this and tell me what the range is? Right, 0 to infinity, including the 0?
Yes.
0, including the 0. So the range is about the y value. So the lowest y value is 0. The highest y value, it goes up forever. Our way of talking about going up forever, which we'll talk a lot about in calculus, is infinity. Okay. We have a lot to say about infinity in calculus. Okay. So it seems like I'm able to talk about this graph by using, about whether this graph is a function by using this vertical line. It's called the vertical line test. Right? What does the vertical line test say? The graph of f is a function. I know, thrilling. The graph of f is a function if what? What are you going to do with the vertical line?
If that vertical line only passes through one point for x.
Right. If every vertical line that intersects the graph intersects how many times? Once. And only once. We're about to crush problem number 2. So the downside to this method of teaching is I control the board, right? So that I can move to something else. If you need me to come back to this, please tell me and I will do that, right? It's locked in there. Okay. Function? No. Does not pass. Whew. Does not pass the vertical line test. Okay. Let's get to it. Function? Y equals -1, right? That's the line y equals -1. Why is that the line y equals -1? We'll talk about that. On this line, what happens when x is 1? What's y? What happens when x is 10? Right, for every x, y is -1. Right? Function?
No.
Function?
Yes.
Function? No. What graph do you think that is, right? So it's not that one, right? Function? What does that one look like?
Sine.
Looks like a trig function. It's not sine, it's negative sine. But it looks like a sine function, right? Function?
Yes.
Yeah, cubic. Right. Questions? Vertical line test. Oh, yes. Let's see if we got them right. It's good because I get to do these and I blame you if they're wrong. I have, what's great about My Open Math is that they will present functions to you in all sorts of ways, and this is purposeful. Here we just have a table, right? Which ones are functions? For each x, there should only be one y. First one, function? Why not? 2 goes to 2 different things. This one? Good. Can someone give me the street version for these? The x column, numbers in the x column should only appear one time. If you only see it once, it's over, right? Questions about this? Good. So, and this is what I meant. This is what I meant by we're going to start in the same place, but oh my goodness, we're going to ramp it up as we go along. It's going to be crazy. I'm thrilled and excited about it. Right? We're all going to start off nice and easy. First week, same thing. 1-to-1. Oh, I'm sorry. Please go ahead.
So X can't repeat itself to Y.
Say that one more time.
So X can't repeat itself to Y.
Y can. That's right. That's right. All right. So again, the way to think about it is that it's okay for two of us to be the same age. It is not okay for me to have two ages. Oh my goodness. I'm so addicted to head nods. People nod their head. It's just great. 1-to-1. Street version of 1-to-1 means that for each X there's only one Y, and for each Y there's only one X. 1-to-1. That's the street version. Now the mathematical version, sometimes the mathematical version that becomes popular is one that doesn't seem to make a lot of sense. 1-to-1. Here's the mathematical version, and then I'm actually going to write the street version as well. F is 1-to-1 if, here's the mathematical, well, let me get the street version first. F, so here's the street version. If for each X there is only one Y, and for each Y there is only one X. Great. 1-to-1. Here's the mathematical version. Each Y only comes from one X. Each Y only comes from one X. Here's how we say it in mathematics. I'm going to come into this room, and everyone's going to be a different age. So now, right now, by the way, is the function that we talked about, the age function for us, is that 1-to-1? No, we got a ton of people who are 17, right? If we wanted to make this 1-to-1, and we do this with inverse trig functions, right? If we wanted to make this 1-to-1, what would we have to do to some of those 17-year-olds? They need to leave, right? I cannot have more than one 17-year-old if I want to make this 1-to-1. Because only one person can be 17, okay? Say it again? I know, there'll be you. It'll just be you and I, right? So, okay, but I'm going to do that, right? So let's do something else. Let's do height. Anybody who's 5'10"? You're 5'10"? Okay, then I guess I'm going to leave along with 3 of you. My brother gets to stay, right? And then I got some 5'6" people, right? So, okay, great. And then so I'm going to make that 1-to-1. So any repeats have to go, right? I then come into the room. Now it's 1-to-1. I come into the room and I say, who's 5'6"? Who's my 5'6" person? Yes, your name? Daphne? I come into the room, and then you and I are talking, and I go into the room and I say, yo, I just talked to Daphne, she's 5'6", right? I leave the room, and then you go into the room and you talk to somebody who's 5'6". You come out, and then you talk to me, and you say, you talk to the person who's 5'6". Who is that person? Who's 5'6"? Daphne. Right, has to be that person. That is to say the following. That is to say that if F is the 1-to-1, if I told you that A and B give you the same result, then what must be true about A and B?
If it's the same.
They better be the same. If F of A, let me pick one of these. So I'm either going to use the arrows or I'm going to use then. I shouldn't use both. If F of A is equal to F of B, then A must equal B. A has to equal B. F represents the y coordinate, right? Two y coordinates that are the same have to come from the same thing. For each y coordinate can only come from one thing. That's the way we write one-to-one in mathematics. F is one-to-one. If I give you two things that give you the same thing, they better be the same. Okay. But the way we're going to think about it, for each x, there's only one y, and for each y, there's only one x. For each x, there's only one y, and for each y, there's only one x. For each x, there's only one y, and for each y, there's only one x. For each x, there's only one y, and for each y, there's only one x. One-to-one? No. Not one-to-one. There's a y coordinate that seems to have two x coordinates associated with it, namely the square root of 2 and the negative square root of 2. So it seems like, in an inverse type of way, that one-to-one just means that when you switch the x's and y's, it better be a function. Right? So that does not pass the horizontal line test. Right? Okay, so f is one-to-one. I'm not going to write this. F is one-to-one. The graph of f is one-to-one if every horizontal line that intersects it once and only once. Please go ahead.
So does that mean one-to-one problems can only be like, just like, it's right there, not exponential, linear, yeah, linear slope.
Linear slopes, not linear slopes, right? So just like you were saying, right, e to the x, right? We're going to talk about e to the x. There's e to the x. I haven't defined it. Is that one-to-one? It better be, because I plan on taking the inverse. I do, right? So I plan on switching the x's and y's on that one, right? I'm going to call that the log. Okay. So that's one-to-one, but that's not linear. Right, so you're saying something else. It has to be doing one of two things. If I have a continuous one-to-one function, it needs to be doing one thing or the other thing. What is that thing? So let me talk about it. Oh. All right, I'm going to draw a function. Here we go. All right, you tell me whether it's one-to-one or not, okay? One-to-one?
Yes.
One-to-one?
Yes.
One-to-one?
No.
Oh, okay. I screwed up? Okay, this time I'm not going to screw up. One-to-one?
Yes.
One-to-one?
Yes.
One-to-one. Oh, what happened?
You had it.
If I want it to be one-to-one, it has to be either going
One direction.
one direction, meaning going up the whole time, or going down the whole time. That's exactly what she was trying to say. That's you and I secret. All right, okay, good. So a continuous one-to-one function is always increasing or always decreasing. So whenever you see it, so the street version is, if it comes back down, no. If it was going down and comes back up, no. Not going to be one-to-one, okay? Makes this pretty straightforward. In terms of just the table, for each x, there's only one y. For each y, there's only one x. What does that mean in terms of the street version? Each row, the number should only appear once. First one, is the first one one-to-one? Is the first one a function?
Yes.
Excellent. The first one's a function, street version. The first one's a function because all the numbers in the first row appear once. The numbers in the second row don't appear once, so that's a no. Mathematically, we have two x's that go to the same y, or we have one y coming from two x's, or mathematically, here I have a number 9. F of 6 is 9. F of 12 is 9, but is 6 equal to 12? No. So it can't be one-to-one. One-to-one? 1 to 1? Questions? I'm going to burn through this first homework, right? We just talked about this. 1 to 1?
Yes. Oh no.
This was kind of hard. That's the real question, isn't it, brother? For sure. Yeah, so I can. That's too much. Yeah, that's too much. There's no amount of zooming that's going on. There's a question you want to ask me. What do you want to ask me?
Is that a function?
Yes, right? You're asking me, is this a function, right? So the question is, what about this? Is this vertical or not, right? It's not. It's not. It's moving left to right the whole time.
Can you explain that?
Explain what?
Can you explain why it's not vertical?
That's a great question. Oh my goodness. And that is a calculus question, right? Oh, wait one second. That doesn't mean I'm not going to answer it. It just means that that's a calculus question, right? So the calculus question is, how fast is this changing, right? So here, and so what we mean by that is, what's the slope, right? Why am I pointing at this, right? It means, what's the slope here, right? What's the slope there, right? And so the slope here might be, wait, first of all, is the slope here positive or negative?
Positive.
Positive, because it's going up, right? Going up, going up. Is the slope here positive or negative? Is the slope here more or less than 1?
Less.
How do you know?
Because it's going to go up 1 and 1.
Right, because the slope a slope of 1 would go from here to here, right?
Yeah.
That's the slope of 1. 1 over 1 up. 1 over 1 up. The slope should look like this, right? And this is clearly flatter than that, right? What's the slope here?
Pretty big.
Say it again. It's really big. What's our way of saying really big? It's infinite. It's infinite, right? So the calculus way, so we would say in calculus that the slope at this point is infinity because it's vertical. But the question becomes, wait, if it's vertical here, how are we moving left to right? So we can be infinite at a point. You can be moving, yes, there's the example. There's the example.
So is that a function that's 1 to 1?
This one is 1 to 1. Absolutely.
And it's vertical.
And it's vertical. That's right. At that moment, not on an interval, at that particular moment, the slope is infinite. That's right. Pure calculus question. Yeah, go ahead.
So, like, if it was for a longer time, like, if that, like, was, like, over...
So it's a longer y interval. Like if it goes up like this,
Yeah.
then it wouldn't even be a function.
Okay.
Yeah, it wouldn't even be a function. Yeah. But it's just for that moment that the slope is infinite. Now, good. Yes.
So at that moment, like the slope cannot be calculated.
That's correct. It has no slope there. So in calculus, you'll be able to find the slope everywhere except for that one place. That's the cube root of x. I've just moved the cube root of x 1 unit over 1 unit down. That's the cube root of 1 unit to the right, means I need to do x minus 1. Oh my goodness, I'm ready for this. I got some people who are ready to do this. So it's the cube root of x minus 1, right? And that's what this is. And so if you graph that, we can put that on Desmos, right? I think it's a cube root. Cube root is x to what power? 1/3. Good. So x to the 1/3. That thing, right? I need to go in. We'll talk about all this stuff. That one is not exactly the one I have, right? I got this, right? And so I need to move it 1 unit to the right. Minus 1. And I need to move it 1 unit down. Minus 1. Right? So there's the point right there. 1, 1. I'm sorry. oh, let's do this. The point 1 comma -1, right? It's right there. And the slope there is undefined. But for each x, there's only one y. For each y, there's only one x. This function is 1 to 1. Please go ahead.
So like at that point, what was vertical? Like any bit above that.
Any bit above that, the whole thing breaks down. And that's what calculus is about. It's about, yo, not that I drove home from here 60 miles in 1 hour. Everybody knows I drove 60 miles an hour. The question is, when I drove by the cop going 80 miles an hour, the moment he puts the radar on me, right? So that at that moment, I'm going 80 miles an hour. Not for 5 seconds, at that instant. At that instant, right? That's a hard problem. So that we're not asking for, we're going to do this in this week. We're going to ask for, well, what's the slope between here and here? The calculus question is, what's the slope there? Right? What's the slope right there? Okay. Okay, excellent. All right, so again, my computer's fast. We got about 5 minutes. All right, let's see how many more of these we can do to get you ready to do this. All right. 1 to 1?
Yep.
Why? Pass the vertical and horizontal line test. Give me another reason. Going up the whole way. Give me another reason. For each x, there's one y. For each y, there's one x. See, those are the ways we're talking about, right? Got so many ways to explain it. It means that you understand what's going on. Oh, one of my favorite functions. 1 to 1? No. No. 1 to 1? Not even a function. 1 to 1? Yes. 1 to 1?
Yes.
That's like the square root of x, flipped all over the place. Okay, so I think we clicked all the right ones. Let's see. This one has 5 attempts. So again, yeah, if you get these wrong, for some reason this one you get 5 attempts. I don't know why. Usually for a lot of them you get an unlimited number of attempts. But yeah, you get 5 attempts, and then they ask you, would you like to do another one that's similar? And then you click on that, and then it lets you replace the credit. Okay, so again, you have a chance to make all of these hundreds. Excellent. Let's burn through these. All right. F of 3. Is this a function?
No.
Is this a function?
Yes.
Is it 1 to 1? No. Okay. So at least it's a function. So for each x, there's only one y. So 3 should go to 1 and only one number. What number is it? 3. Right. So 3 is assigned to -3. So you go to 3 on the x coordinate, and we know now for this 3, when we go along the vertical line x equals 3, because this is a function, there should only be one y coordinate associated with it. And we look at the line x equals 3 and it intersects here. The y coordinate is -3. -3. All right. As we go along, again, I'll try and get a feel of what's hard, what's easy, so that I can continue to challenge you. All right, so let's answer this one. What number is this? Number 7? Number 7. Is that a function? Yeah. All right, dealing with some language. F of 2. F of 2 is 3. F of 2 is 3. Is this 1 to 1? Yeah. So this makes sense. There is a number that gets associated with this y coordinate. What number is associated with 2? 4. So there's a number that's associated with this y coordinate. It is 4. is presented to you in a different way. Is f a function? Yeah. Right, all those numbers in the first row are different. Looks like it is 1-to-1, right? All the numbers in the second row are also different. For each x, there's only one y. For each y, there's only one x. What gets associated to 3 and 4? What associates itself with 2? What is it? 4. Questions on that? Great. Oh, and then we can start plugging in. We'll stop there. All right, tomorrow we'll start here for number 9 on the homework. Again, tonight we can work through this whole assignment into the future ones if you like. I'll be rolling until 9 p.m. tonight so I can find my TA wherever she is in this world. This stuff, all this homework and a bunch of other homeworks are due Sunday at 11:59 p.m. There is study sessions on Sunday. I will be there if I can't find my TA, so I'm really going to be looking for her. So, but otherwise, we'll have fun nonetheless. Thank you.
Thank you, Dr.
Let's see how big this thing is. 82.